Hey everyone, welcome to the Road to Agentic AI. In this series, we break down the tech behind how Agentic AI is transforming work, helping to scale capacity, cut down manual tasks, and free teams to focus on strategic objectives. Last time we looked at how large language models work, but today we're going to tackle prompting. Every word we use in a prompt shapes probability, either narrowing or widening outcomes. Prompt engineering isn't just about instructing the model, it's about architecting probability towards the goals that we want. So today, with examples and explanations, we'll explore what all that means. Quick intro, I'm Jules, CISO for Prowse Consulting, and an advocate for Agentic AI. If you have questions, feel free to use the email below. But now, let's get to today's topic, prompt design as system design. Hi everyone. Welcome to this second session of the Agentic AI Brown Bags, where we're going to talk about prompts, and the topic is prompt design as system design. So let's get stuck into it. So to pick up from where we left off in the last presentation, we focused on this idea that large language models and other generative AI tools don't actually think. They just predict tokens by using sophisticated probabilistic math. At the end of that session, we talked about this idea of what does that actually empower us to do with these tools? And the answer is it gives us the ability to control generating output in intentional, nuanced, and creative ways. So we're going to focus on prompting today, not necessarily from a kind of like way to make better prompts, but to really look at how the prompt itself is kind of like designing a system that generates a specific type of output. Specifically, when designing this system, what can we do to maximize the kind of outputs that we want? And just as last time, this is kind of where we sit in this flow of different topics that will lead up to talking about Agentic AI. So most of us have used large language models quite a bit, and a lot of the examples you're going to see might not necessarily even feel that new to you. Lots of people use large language models for technical writing or editing or all sorts of other knowledge tasks. This isn't really about making a cool demo. This is more about talking about how AI actually functions. And we're going to go into that and try to figure out if we can pull out the parts that show how we're actually designing probability. So the question for today to keep in mind is, can you see what parts of a prompt shape the probability of the response? As we talked about last time, large language models are actually only capable of doing one thing, which is predicting the most likely next token based on the prompt. Which means your job isn't really about giving them instructions, even though it seems like it. Your role is to shape that probability space, to create a landscape that allows the thing that you want to be the most natural thing to come out of it. So let's move on and talk a little bit about this subject. We'll start by talking about exactly what a prompt is. Prompts, the best way to think about prompts are basically the input we provide to shape a probability space for statistically likely token prediction, right? They create this kind of landscape. And in this landscape, from the shape of it, more of different words are more likely to appear because of how it's shaped. That means that prompts, if you think about them this way, aren't really queries or even requests. You're still the only person who understands your intent, what you want. So shifting your thinking to this kind of landscape metaphor might be a little difficult at first. It might even seem a bit pedantic, but really try to think about it that way. Try to think about this as a probability landscape that causes things to happen instead of just thinking about it as a straightforward question. If you understand this, much more complicated things that will come later will become a lot easier to understand. So let's have a look at this really simple question. What is the capital of France? Instead of thinking about it as an actual question, let's try to think about it as a collection of tokens that suggest a highly likely next token. So if we have a goal of wanting the output of the word Paris, we've basically designed a little system here which can produce that output. We've designed a probability space that produces the output Paris. So even though it looks like a question, this is more like a mathematical landscape where all the tokens that are present in this sentence and even the order in which they're placed, and even the inclusion of a question mark at the end, is designed to give the output that we want. And so even with all that said, some of you might feel like, okay, what's the point of this? We get it. It's math underneath, and that's producing the result. That's great. Even if it's not really a question, why do we care? Like, questions do work. Lots of people have used ChatGPT billions of times and asked it a question and got an answer back. It's true. That is a pattern that works. But it's maybe more accurate to say that question-like structures influence the probability of answer-like replies. And that is why it's relevant in this particular case. However, if you just think about it that way, it actually limits what you're going to be able to do with large language models, because the large language model doesn't understand really what a question is or your intent. Have you ever had a moment where you've used ChatGPT or any large language model and thought, why did it ignore this part of the prompt? Does that change if you think about the fact that the model can't actually understand your prompt? In fact, it can't even really ignore you. In this case, it's just that the probability of the result that you were aiming for was too low for it to come out in the output. The reason that we're focusing on this mindset shift so carefully is because without understanding this, you can't really design away from bad results. You can't fix what you're doing. So our objective here is clear. We're trying to shape probability to reflect intent. There's this term called prompt engineering, which has become kind of popular, which is essentially talking about ways in which you can write prompts that give you this kind of ability to shape probability. We're going to look at a couple today and some in the next session. But for today, we're going to focus on prompt writing and context shaping techniques, and we'll just go through these one by one. So first up, let's imagine that we're writing a blog post and we want to use some AI to help us write this post. We've got two examples of different prompts that you could use to get started with this. The first one is, I need useful facts about Seattle's coffee culture. And the second one is this longer one, which talks about writing a blog post specifically, aiming to blend commentary of historical context, social dynamics, and statistics to paint a compelling story of how it's distinct, provide me with some ideas and facts, and a structured outline. Okay, so let's get this out of the way. One of these prompts is definitely more detailed than the other, and that's obviously going to influence the sort of thing that happens, but let's look beyond the actual just length of the prompt and talk about what this extra detail is actually doing, what function it provides. Prompt 2's language is trying to shape the model's token probability space more precisely. We're pulling the response into a narrower kind of pattern. Narrative, structured, we've got specific topics, and we're even using this kind of structural pattern of a blog outline as the frame for how the probability is going to be directed. Here's the truth. Both of these are going to actually contain a lot of the same stuff because we've already put a very large cluster of probability in there by just saying Seattle and coffee culture. There's a lot of things in terms of probability that are going to be attracted to this idea. If we have a look at the results from the simplistic prompt, we can see that as we predicted, there's a lot of useful facts that come out from Copilot here. And it's got a couple of, it's even got citations, it looks like. The tone is sort of conversational and informative, kind of like it's trying to teach you about something. The format is a bit unstructured, and we've got kind of like facts and influences and different things that are sort of different topics, but they overlap a little bit. This isn't really bad output. This is still helpful. And you could use this to inform writing a blog, but it's not very specific. It's very broad in terms of how the output's been structured. So the model's just doing what we wanted it to do, basically look for stuff to do with Seattle and coffee. But if we look at our example with the more specific prompt, we'll notice that it's actually come out with a very different structure. We've got these logically separated sections. The information is at the outline level, and it's not conversational. It's sort of talking about topics at the higher level. The tone is much more direct. And we can also see that the other things that we included in the prompt to do with history and social dynamics are being pulled out into these different categories intentionally. The model didn't get more intelligent when it produced this output. We just made it more likely to say things that align with our objective by including those things in the prompt. Let's move on to a different example to do with personas and scenarios. It's a common technique for influencing the sort of output that you get from working with large language models. So we've got this prompt here, which rather generically says, describe the typical first-time experience using a food delivery app. So we put this prompt in and we get an output from Copilot that has this very kind of like, you've probably seen this kind of output before. It's very common. It's a little upbeat. It's a little whimsical. It's using very common idiom, easy to understand phrasing. It's basically a very high probability general way of talking about this. There's not much personality in this. It just tends to be kind of the sort of helpful assistant persona, which is sort of the default for a lot of these large language models. Now, what we're going to do next is shift the prompt's framing just a little bit and see what happens to the probability space. So our new prompt is, you are a noir detective describing your first time using a food delivery app in a rain-drenched city full of secrets. Now, this prompt is a little silly, but basically the idea here is showing how we've basically added a handful of words to this sentence, the prompt that we had last time. And the result that comes out is actually really very stylistically different. It's gritty, cynical, overwrought, melodramatic. It's got these little phrases that you might imagine from a noir novel or something, like a busted radiator and a slug from a 38, chalk outline. These things are all parts of the probability space that the output gets attracted to because they're part of a larger pattern. Despite all of this, the actual underlying story that gets output here is pretty similar to the bland one that we just looked at previously. So really what we've done by including these terms is just influence probability in a very specific direction. We've shifted it into a place with strong, well-formed patterns. You might look at this example and think, this is a bit funny. Like, how is this really teaching us what we're trying to learn in this session? We're framing it this way to show how clearly you can see this kind of influence. Focus for a moment on the idea of shaping the probability space. In this case, with the noir city, we can kind of intuitively almost imagine it as an actual city, right? We can think of things like jazz, cigarette smoke, black and white film, thunderstorms. These are all things that feel likely to exist in this space. They're highly probable things that might exist in this space, right? Pattern-based token prediction is basically the same thing. We're looking for statistical patterns of how people in certain roles or situations tend to speak and behave. It's not magic. It's just the same probabilistic math that we've seen so far. These patterns are present latently in the billions of examples of training data that the model has. And so some other ways we could influence this text in the same way is by using a different persona, like saying something like, explain this as if you're narrating a children's book, or you're a sarcastic movie critic, or you're a cybersecurity analyst specializing in cryptography. This way, we can influence the kind of output that we're getting by constraining the probability space. Likewise, you can use scenarios to do the same thing. Instead of just emailing a client, we can be emailing a client after 12 months of silence. And this will change all of the different probability, all of the different elements in the probability space. So all of these things shift the generated style, tone, voice, content, and subtext of the responses that we get from the LLM. So let's continue down this line of thinking. If we think about things like blogs and noir as a style pattern, what about strictly designed patterns like bulleted lists or tables of data? What about even something like a haiku or a sonnet? We could even go further and say a web page written in HTML. Because what are these if not just structured patterns? Of course, in the extremely large volume of data that goes into training large language models, these patterns are seen over and over again. Even things that seem kind of restrictive or complicated, like academic papers or poetry, they're natural strengths for large language models because the more consistent the rules that make a pattern are, the more easily it maps into probability, the easier it is for us to guess what would happen next. So what seems complex for us is often pretty easy for a large language model to do because it's seen the underlying structures hundreds of thousands of times before. In fact, its understanding of these structures is so good that we can even start to layer them on top of each other without losing cohesion. So just as a little example of what I mean by that, we could give a prompt like, generate HTML for an elegant web page that contains a 4x3 table of seasonally inspired pickle-related haiku. Each column should correspond to a season, and then style this page in an austere Japanese-inspired color scheme. Okay, so we give it this prompt. And sure enough, we get a nice little HTML web page with pickle-related haiku. What's important here is that what actually got outputted is this HTML in the background here, right? So even though we had this creative task of creating these haiku, it was able to generate that within the rule-bound pattern of HTML with no problem at all. So we were able to use those patterns, the rule-bound patterns of poetry and HTML, cohesively to generate this in a very particular way that we intended. And I said there wouldn't be any like silly tips in this presentation, but one thing I want to actually put in is this idea of positive versus negative prompting. While it's really important to be clear with intent, it's also worth noting that AI tools generally respond to positively phrased prompts better than negatively phrased ones, because all language kind of has a natural tendency to be action-oriented. In other words, we tend to talk more about what we are going to do versus what we aren't going to do, which means in training data, there's more examples for the LLM to draw from that go with positively phrased actions. So instead of writing a prompt that has something like, don't write long replies to over-explain the situation, don't offer follow-up solutions, it's actually probably more useful for us to write something like, write a reply that contains a single actionable solution to the problem in one sentence. This is all positively worded and is much more likely to give you the result that you're looking for. It's not a blanket rule. You can use negatively phrased words, but it's often helpful if you're going to do that to give some context for why. Instead of just saying something like, never use emojis, if you can say something like, your response will be used in a system that can't display emojis, so don't include them in your reply. This extra scaffolding here gives the prediction space a much more specific way of generating the result that you want. So you might get some good results with saying never use emojis, but you'll probably find that you get better results if you also provide context for reasoning. Let's take a pause here, and we'll think about the last three techniques we discussed and why they matter in practice. Clarity of intent allows for assertive, specific alignment with goals. Personas and scenarios enable you to strongly influence tone, style, and content. And rule-bound patterns and structures allow you to adhere useful pre-existing structure or syntax. When you think about it, these are actually all the same concept. We're basically trying to narrow or constrain the probability space. We want the probability of a certain outcome to become more likely. But what if we did the opposite? What kind of outcomes could we get if we deliberately prompt in a way that allows the probability space to expand? Because of the breadth of content in large language model datasets, they can be useful for open-ended tasks like ideation, brainstorming, or creative writing. How much we want to expand or constrain probability is often referred to as temperature. To bring the concept of temperature shaping from an abstract concept into the tangible, try to think of something like a professional chef. Now, cooking is a craft that exists on this kind of spectrum between precision and expression, between tradition and invention, between comfort and surprise. Prompting is similar in that prompting style informs how much we want to constrain or expand the probability of the output. So we've got a little table here which sort of demonstrates maybe like a quick overview of the spectrum of this soft versus precise prompting. So we might have a task like convert my grandma's cookie recipe to HTML. We only want success to look like an exact transcription, but just convert it into HTML. Okay, that's very prescriptive. We might have some slightly more structured, but still open-ended style of prompting, like something warm with chicken and Asian spices. No nuts, I'm allergic. So this allows for some, probabilistic expansion, but also has rules. All the way down to some very vibe-based way of coding, which is something like, I want anything to combat the summer heat. And this is completely open-ended. It could be anything at all. Prompting is how, in this case, we're architecting the chef's behavior. We're not the one actually doing the cooking, but you're responsible for the order. Let's have a look at an example here. Let's say we worked for a company that makes cat beds, and we wanted to make some marketing copy to be used for a new cat bed product that's going to be released. If we take a low temperature approach, we might write something like this. Write a short product description for a cat bed, include material, size, and comfort level. Keep it professional. And we get this product name, like the Soft Nest Cat Cushion 45, and we get very predictable and professional sounding output. But we could also take an approach and write a prompt which encourages creativity. Describe a luxury cat bed like it's a royal throne for feline nobility. And we get a product name that looks completely different. The Velvet Pawless Meowjesty Lounger, and this very sort of like vibes-based explanation. So we have control based on the task of what kind of probability space we want to operate in. Do we want it to be open and broad, or do we want it to be constrained and specific? So far we've looked at how one prompt can shape useful, precise, or creative results, but every token that gets added into an LLM session is working to influence the next output. This includes all previous prompts and responses. In this way, prompting can better be thought of as your turn to manually contribute to shaping a continuous context. The context shaping is a pretty broad topic, but we're going to focus on two facets. Priming, which is giving additional information before prompting, and iteration, which is responding in a series of different replies to refine, redirect, or expand the direction of probability after response. Both of these work in the same way, even though they look a little different here. If this probability space we're talking about as a landscape, context is like its geography, its landmarks and features. The more detailed we make the scene, the more cohesively the model can simulate what would naturally unfold in that landscape. So let's have a look at how that might actually play out in practice. Imagine you work for the same fictional company here we've got making pet products, and your goal is to develop a brief memo based on Q2 performance. Using existing artifacts as priming content, how far can we get with this? So let's intentionally use a vague and pretty badly worded prompt, but we're going to pair it with text file copy of the previous memo and an Excel document of Q1 and Q2 sales numbers, customer satisfaction, and other statistics that go across different product lines. So what we've ended up with here is this Q1 memo text file, an Excel document with sales data, and our minimal prompt, which is just use the two documents to make a memo for Q2. Now, this prompt by itself doesn't do anything. Like it will generate something that will probably be a bland, completely invented Q2 memo. But if we use these two artifacts to prime the large language model, we'll get a different, more specific result. And so we don't have to go in and open these files to have a look at specifically what's going on. Let's look at the output and see what kind of things got put into it. It strongly resembles the format of the previous memo, referencing the same subjects, measurements of performance, and utilizing similar phrasing and language. It contains conclusions synthesized from provided data with aggregate and average numbers. So context priming is a very powerful technique, and it's something that will probably be focused on a lot more in our later sessions when we talk about how to use agentic AI, because it's one of the absolutely pivotal parts of making a good agentic system, is controlling what context you prime an agent with. But for now, consider using this technique whenever you want to do tasks that involve something like transferring style, or combining or comparing data, or continuing a previous narrative. For example, if you are writing a blog post, you might even include a previous blog post in the target style that you want, as a way of saying, use this as a reference for how we want to sound with our brand. Okay, so from seeing this explanation of context priming before prompting, you may have understood the connection we were trying to make earlier. All prompts and all responses are also context priming. This perspective allows us to intentionally build context towards an objective that we ultimately want to arrive at. So take a look at these three prompts here. The first one says, summarize the attached software release notes into 3 bullet points. And then we get a response back from the large language model. So our second prompt is, make 2 versions, one focused on system performance and one based on compatibility. Okay, now we've got these 2 different versions that are outputted. The third prompt is, can you simplify the system performance version for a non-technical audience? Now, by using this sort of cascade of probabilities that we've developed, we can intentionally guide the direction of what we want in a specific way. So we've basically added detail into the context with each step, not just the prompts that we're writing, but also the output that the large language model has built. So basically, longer context with more context priming can build more specifically aligned results. It allows us to clarify our objectives step by step, avoiding logistical overlap or confusion with a single overstuffed prompt. And it also, interestingly, plays to the strengths of people and large language models, mimicking intuitive collaboration patterns. At the very start of this presentation, I asked you to think about not just what works, but why. Let's look at that last prompt again. Make 2 versions, one focused on system performance and one based on compatibility. So this was the release note summary that we were talking about in the previous slide. There's something weird about this particular one. To answer this prompt, 2 abstractions must be discriminated between. Which features relate to system performance and which ones relate to compatibility? Well, hold on a second. We know this model can't think. It doesn't really comprehend the concepts in the prompt. In fact, everything we've discussed today is just probabilistic pattern matching. So how is this happening? This is a completely new thing that we've given it here. Comparison requires you to reason, right? Let's propose an idea that might seem difficult to grasp at first. What if the paths we trace when we do reasoning as people, categorizing, contrasting, ranking, what if those themselves are actually also patterns? If the way in which humans solve reasoning problems tends to follow similar repeatable paths, then wouldn't it follow that these patterns, when spoken aloud or written in text, like in the model's training data, create a kind of linguistic shadow of how to reason? The answer, surprisingly, is yes. And that means that even reasoning itself becomes something that can be modeled probabilistically. Well, we're about at the end of our 30-minute session for today, but everything today was centered around this core idea. Prompts systematically create a probability space that we can design to influence output. We talked about prompting with intent and clarity, influencing output style with framing and scenarios, utilizing conceptual patterns to guide generation, and context design via context priming and iteration. And we concluded with this pretty thought-provoking idea. If it's patterns that allow us to create a rain-drenched noir-themed city, or output neatly formatted HTML, and that reasoning itself is also a pattern, where does that take us next? In our next session, we'll explore how seemingly reasoned outputs emerge from patterns and what it means to think with a latent space instead of just prompting into one. Thanks again for joining us on the road to Agentic AI. I hope you found today's insights helpful. Next session, we're going to look at the concept of latent space and further expand our understanding of large language model systems. Check your inbox for upcoming episodes and feel free to reach out with questions or feedback. Cheers.